First of all, a little bit of recognition. So part of what is going to help you in math leading forward is recognizing things before they even happen. So we're solving this one. It's got a cos squared and a cos. Whenever you have something squared, that's a quadratic equation. So you solved those all last year in grade 11. X squared plus x plus 5 equals 0. And when you had those, what were ways that you solved them? Well, you made one side equal to 0, right? And then you factored. And if you couldn't factor, well, you can't. And if there's a cos squared and a cos, you won't be able to square root because there's two different functions. You could either complete the square or use the quadratic formula. Okay? So hopefully we can factor, because factoring is the fastest way to solve it. But if you can't factor, you'll have to go to your quadratic formula or use completing the square. But for most of you at this time, if you can't factor it, you'll probably go to the quadratic formula. For one, it's on your formula sheet, and it's just as quick as completing the square. So for part A, we notice that it's quadratic. The first thing we're going to do is move everything over to one side so that it's equal to 0. I personally, when I move things over, I like to make whatever was squared positive. So I look at my equation. I've got a negative 3 cos squared x. I'm going to move everything over to the left. So I'm going to add 3 cos squared x to both sides. I'm going to subtract 1 on both sides and make one side equal to 0. The next thing I would do is I would try to factor it. This one is not a hard one if it were factorable. It's not a hard one to factor because one of the things that we've been looking at when we're factoring is we know that if it can be factored, the first ones have to multiply to be 3 cos squared x. The last ones have to multiply to be 1. And since those are both prime numbers, this makes this the easiest one to factor if it's possible. Because the only possibility for our first ones with the nice numbers is 3 cos and cos x. And since the last number is a 1, the only possibility, if it's factorable, is 1 and 1. So now we would just have to check positive and negative signs in between to see if it works. Now I can tell already that this is not going to work. Why? Because if I look at my outside, it makes 3. If I look at my inside values, they make 1. And whether I'm adding or subtracting, 3 and 1 will never get me 1 in the middle. So by trying to factor it, I also realize this can't be factored. It's not possible to factor this. So if it's not possible to factor, that means we're going to have to go to our quadratic formula. Now on your formula sheet for this year, it has this. For ax squared plus bx plus c equals 0, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we don't have x squared in our equation. What do we have squared? We have cos squared. So for us, when we're writing this solution, instead of writing x equals, we'll write cos x equals negative b, so it'll be negative 1 plus or minus the square root 1 squared minus 4, a is 3, c is negative 1 over 2 times 3. So simplifying this, we get negative 1 plus or minus the square root of 13 over 6. So we're going to go to our calculator to type that in. Again, this will make sense for us to use our fraction button. On the top, we have -1. Now, because it's plus or minus, we're going to have to do it once with a plus sign. Second square root of 13 over 6. Find out one answer. And we're going to have to do another answer. So if we retype this, probably the quickest to just go back and change the plus sign to a minus sign, and we get our second answer. So this means one answer is 0.434, another answer is -0.767. All right, so there we have our possible answers. What does that mean? Well, it probably makes sense for us, instead of writing it this way, to write them out separately. That means cos x could be 0.434, and cos x could be -0.768. Are those values on your pie plate? Yeah. Oh, yeah. No. Okay. They are possible, right, because they're less than 1. Often when you use the quadratic formula with sine or cos, one of them ends up being 1 point something or 2 point something. You get one answer that's not possible. But in this case, both of our answers are possible. So we start, calculator question, we're going to need to find our reference angle for 0.434. So sine inverse. And one thing that's important to do, so I'm going to go sine inverse. When I'm going to get my reference angle, I don't want to round. It's cos. Okay, thanks. That'll save me some time later when my answer's wrong. So one thing I want to do is notice how I went up to my previous answer there and selected it. That way I'm using all of the decimal places. If you don't have a new calculator that lets you go up to those, then when you get answers that you're going to need for later, you're going to want to use your store button so that you can store those answers. So now I have my reference angle is 1.12. So my reference angle here is 1.12. It wants things to the nearest hundredth, so that'll be good. And cos is positive in quadrant 1, so I'll get 1.12. And in quadrant 4, in order to find my answer in quadrant 4, two pi minus my reference angle, 5.16. So there's my answer in quadrant 1 and quadrant 4. I'm going to go to my other answer. Again, I'm going to find my reference angle by doing cos inverse. Cos inverse of, now this answer has a negative. And we always find our reference angle with the positive value. So you can either use your arrow key and go over until you get to that negative and delete it. Or maybe quicker, we'll be multiplying by a -1, because that would just change it to positive. So that way, I've got my reference angle with the positive value. So my reference angle is 0.70. Here, cos is negative. Store that as x. Cos is negative in quadrant 2 and quadrant 3. So in quadrant 2, I'll go pi minus my reference angle. In quadrant 3, I'll go pi plus my reference angle, 2.45 and 3.84. So we sort of get into autopilot of always solving between 0 and 2 pi. I hope it also becomes part of your nature that once you solve it between 0 and 2 pi, you go back and check, was that the domain that I was asked for? And in this case, you were asked for between negative pi and pi. So now, negative pi and pi means that we're going from 0 to negative pi in the negative direction and 0 to pi in the positive direction. So which of these answers are good? The first one, 1.12, and 2.45. Those ones are good. These ones are outside of our domain. So how do we find those? First of all, do you remember that this one was in quadrant 4? So then you'd have negative 1.12 for that one. This one was in quadrant 3. So you're going to need to think of using the reference angle and going pi minus. Can you see that we already have that number? It's going to be negative 2.45. Because if you did pi minus 0.7, we did that already to get 2.45, and now we're going to get negative 0.245. So there's the answer in the domain that was asked for. And then in part B, for the general solution, we can take all 4 of our answers, 1.12, 2.45, 3.84, and 5.16, and add 2k pi to each of them. Yes? You could have used your new answers too, but I'm just following. When we wrote our general solution instructions in 7.1, we said solve between 0 and 2 pi and then add 2k pi to each of them. So I just took my original 0 to 2 pi answers and added 2k pi to each of them.
Could you just write all the answers and add pi over 2?
Not in this case, and I'll show you why. Okay? So because you're thinking, because I go from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4, why can't I just go 90 degrees in between each of them? Okay? Depends what the reference angle is. Let's say you have a really, really small reference angle, even smaller than what I've drawn here. So I'm going to redraw my axes and say I have a really tiny reference angle. Okay? Can you see that between here and here is going to be more than 90, but between these two is going to be less than 90? Okay? Technically, can you see from quadrant 1 to quadrant 3, it will be 180. And between 2 and 4 would be 180, or pi. So if you wanted to, you could take quadrant 1 and 3 and combine them and say plus k pi. And 2 and 4 and combine those and just use one answer and say plus k pi. Generally, though, when you get to this part in a question, it's kind of nice to be on autopilot and just write them all and go plus 2k pi. It's not necessary. Like, if you overthink things and then mix up which angles you need to go through and make little mistakes, you do get deducted for making mistakes after you have a questions right. So for that reason, I say just keep it simple.
If you use the new answers, can you just do plus or minus?
Yeah, that would be fine. Okay, so for this one, questions 12, 13, and 14, and I believe in question 14, all of those ones you can factor. So if you can factor it, always try to factor it first, because that'll be faster than the quadratic formula. And we'll take the rest of class to work on these.